Well, thank you, Doug, for those kind and not necessarily true words. Hello, all you cool cats and kittens out there. Coming to you live from my garage here in Austin, Texas, where I've kind of over prepared, let's say, for the shelter in place that has been here for at least a couple weeks now. Feels like either 2 years or 3 days. I'm not sure which one. But in any case, let's talk a little bit about security real quick. My background, as Doug said, I've been working with Apex since 2002 when I was back on the Apex team at Oracle in DC. Go Naps. As you can tell, I'm a little bit of an avid fan, missing my baseball. Through the years, I've been at numerous places, authored a couple books, worked at big companies, small companies, etc. But this session usually takes 2 hours, so I'm going to kind of skip the about me part and dive right into this so that we can finish up in time for some questions. So, overview. There hasn't ever been a time where computer security has been more important. And I did this slide before everybody's sitting at home with lots of extra time on their hands. So it's even more important than it was then. Threats are everywhere, all shapes and sizes, all forms, whether it's an internal employee, an external employee, malicious user, state-sponsored hackers, etc. There's really no stopping and no categorizing some of these threats these days. Our job as developers is extraordinarily difficult because we have to stay out in front of this. And there's really no way to guarantee that we are. All we could say is up to now, we think we're secure. It's hard to predict in the future. So it's a constant battle of us trying to be a little bit more crafty and a little bit more rigorous to make sure that these exploits just don't come true. So there's an organization out there called OWASP, the Open Web Application Security Project. They're kind of like a generic security group for anything web. They don't really have any one specific technology that they focus on. And every year, kind of the big thing that comes out of them is they create this top 10 document. Maybe it's every other couple years or so. And this lists what they consider the most common threats which they see with web application development. So this list is a couple years old, but it's pretty accurate still. Number one, injection, right? You've probably heard about that. Broken authentication, sensitive data exposure, etc. We're going to go through each one of these in some degree of detail. The only one that we really could skip is A4, XML external entities. Unless you're processing XML files, then we've got to go back and revisit that one. Insecure deserialization is also something that's not super common with Apex, although with web services, it could start to get to be more of a concern. So let's go through these one at a time and talk about all the different threats you face as an Apex developer, and more importantly, how to mitigate these threats. So tampering is really the first way someone's going to try to mess with your application. Malicious users, state-sponsored users, whoever, stupid users, right, who accidentally do something may try to prod and poke your application for a number of different things to see if they could get in, if they could change a value unexpectedly, if you're protecting your URL. They'll do this by usually manipulating the URL. Excuse me, more sophisticated ones will use SQL injection and cross-site scripting techniques. Now, the good news is Apex out of the box is pretty rock solid secure against all this stuff, as long as you don't do anything. So as soon as you start writing queries, as soon as you start putting in JavaScript or other vectors, changing the attributes of reports, you could potentially open up one of these vectors. So it isn't that big of a risk, but we have to make sure that it's zero risk. And that's the hard part about security, is if there's a little bit of risk there, that's usually not good enough. So let's start with what I consider the most dangerous, URL tampering. You've seen this, and you've probably even done this. You've gone to an application in Apex, and perhaps you've seen at the end of the URL p2 empno 10. So maybe you change that 10 to a 20. or an 11 or a ABC, right? Once you do that, you might notice that the data on the screen changes. And instead of viewing department 10 or employee 10, you're viewing employee 20. This is something called URL tampering. And the reason why I say it's the most dangerous is you don't need to be a developer. Anybody can do it. You typically need one working finger to get this to work, right? You don't need a code or proficiency in any code or a tool. A lot of developers don't always protect against this, particularly those new to Apex, and even more particularly those coming from a client server world where they just don't know about this. So we've basically potentially created a vector for someone to change the value and change what they can see. And that's bad. Think about if you could edit any employee record and see personal information, salary information, bonuses and things like that, that would not go over very well. So Apex, I believe in version 3.1 perhaps, introduced a feature called session state protection. What this does is it generates an additional parameter called a checksum in the URL. It'll then pass that automatically. When you create a link in Apex, you create a link on a column in a report or a button or a branch, you'll see that checksum become part of your URL. If you manipulate that checksum at all, try to change it, try to alter it, one letter is all you have to do, Apex will basically shut it down and say, nope, the checksum has been modified. Somebody did something potentially malicious. Possibly it's just an error, but it's more likely somebody messed with your URL. That's it. You're done. You can no longer manipulate that URL to see data or to pass different parameters or different attributes to page items and set them indiscriminately. Now you have to turn this on. And if you're in, say, the most recent, probably 7 or 8 major releases or dot releases of Apex, it's probably on by default. You'd really have to have an old application that you haven't touched for years to find a version or an application where this is disabled. Once it's on, you then have to go to every page and specify the level of page access protection. By default, in a lot of cases, all your pages will be unrestricted, although starting with at least 5.1, some pages have been created with arguments must have checksum as the default, which is definitely more secure. You could knock it up a couple levels. You can say no arguments allowed, meaning I can call this page from a link, but I can't pass anything to it. Or you could say no URL access, which is the most extreme. You can't enter that URL to get to the page. You have to be branched there through the Apex engine for that to work. Now, one thing to keep in mind here, just because page access protection is on, say, page 2, it doesn't mean you're safe. Page access protection, think of it as a shield, and we put that shield around page 2. So when the user or the malicious user tries to exploit that, they're going to get an error message because they're trying to go to page 2 and pass in P2 depno as 20. What a smart user could do is actually set P2 depno from page 1 and then simply enter in the URL for page 2 without anything after it. Apex will have that value set in session state, and then it will render page 2 with P2 depno set to 20. So there are still ways that if you don't turn on page access protection everywhere, you might be able to circumvent this. Now, in the latest couple releases of Apex, there is a new attribute for items that only keeps their value per request, meaning that if I were to set P2 depno from page 1 and then try to get to page 2, that item value may have already expired because it was only good for this specific request. If you're using older forms, however, that attribute is likely set to per session or disk. So this exploit is still possible, probably with the majority of Apex apps out there today. What you need to do is either protect all your pages and also protect items. So items also have this ability to restrict how you can set the value of an item. Most items will be unrestricted, and if it's not a hidden item, that's perfectly fine. If I could go in and I could type something in, there's really no reason to restrict what I can pass through the URL. But if this is a hidden item or a primary key or something that we just don't want to display, we may want to set it to, I typically do session for checksum required here. Application and user basically map to those two components. It's a little less secure. So session is really the best option here, unless obviously you want to restrict it. So setting that item protection creates a secondary shield. So we know that that's an error, but now when I try to set it via page one, we're going to get an error as well. Little quick slide about that. So it is 19.1, the new way that Apex will remember session state, again, per request and per session. This is to handle the new form type region or in support of the new form region. It's also ratcheting up security so that you'd go in, you'd create a record on page 2 and you'd have 15 items. Those items session state would continue to be set no matter where else you went in the app. There's really no good reason to keep that session state available. All it does is kind of drag sensitive data around with you. So it is much more secure to do the per request memory. But there will be times when you need to flip it over to per session. Hidden items. So you've seen hidden items before. They don't display, obviously, when the page is rendered, but they are rendered in the HTML. It's pretty easy to see a hidden item, and this is kind of an older simplified version, but they look like this if you look at the source of your page. The ID being the name. This is the older name nomenclature. You likely won't see that anymore. But if I could go and use a browser tool to see this, I could set this. So it's pretty easy for me to change value to 456 and then submit the page. So again, maybe I edit my own record or somebody else's record who works for me where I can change the bonus. And then before I submit the page, I set the primary key to mine, and then I'm actually updating my record. Again, pretty easy to mitigate this. Simply turn on item level protection. This will prevent people from using JavaScript or editing rather the items, making a change and submitting the page. Apex, again, will kind of stop in its tracks and say, hey, this item was 1, 2, 3 when I rendered it. Now it's 4, 5, 6. We're not going to move forward here. SQL injection, another form of tampering here. This is pretty common, I think, these days. A lot of people didn't know about it maybe 4 or 5 years ago, but I think most of us have at least heard of it. So let's really review quickly what it can do. Imagine giving the user the ability to change your query, right? So rather than applying a filter such as last name equals some value that the user input, that value literally rewrites the functionality of your query. Now, usually for the worse, right? No one's going to do SQL injection to make your stuff better. They're going to do it to pry data out of your system. It's possible to inject both DDL and DML. So if you want to be a jerk, you might drop a bunch of tables. If you want to be sly, you might pull data out that you otherwise weren't supposed to see. Minimally, it's a pain, right? So if some tables get dropped, you got to call the DBA, roll back, probably lose a little data, maybe not a lot, maybe none. But in any case, there's some downtime, there's some disruption. Worst case, it's catastrophic, and you're the discussion of the tech media for a week or two, because these days there's just so many of these. No one really gets to be in the spotlight that long, which I guess is a good byproduct of a lot of these attacks. So the thing here that scares me when it comes to SQL injection is there's really no good or bad SQL injection type flaw, right? If there's a flaw, I could do whatever I want to. I'm only limited by the time and my skill, and which is rarely implemented, the database privileges of the schema what I'm connecting to. Most people don't really lock that down. Their database schema can create tables, can see a lot of tables, can do a lot of stuff. So I can act as if I were connected directly to the database as that schema. So using this as an example, this might be someone who doesn't understand the Apex syntax yet. It might be a Java developer or a .NET developer who's used to writing queries a little bit differently. If they wrote this query, What I could start doing is passing through some unnatural text, right? In this case, union, select empno ename to car sal, alias that to job from emp, and then just kind of make sure that the syntax is correct. So this innocent query, which previously was designed to just show employee number, name, and job, is now union with employee number, name, and salary. Definitely not an employee lookup tool I'd want to have at my company, right? Lots of bad stuff can happen for this. And we're not just limited to unioning the same table. We could union any table. So in this case, I might go after sys.all users. And if I don't have a date, or if I don't have a data type, or just don't feel like it, I'll just put a null. Again, I've got time, so I'll figure out what the data types are. I know I've got experience, so I know that sys.all users is going to give me a really nice open view of every user in the database. And now I've got a list of all your users. What can I do with that? It depends. Social engineering. I could use it to be a building block, or now I know other targets to go after. Or I just sit there and start pulling stuff off, all your different views, right? So all source, all your code. Now I've got a listing of all your PL SQL code, and I could sit back and crack open one of these and basically analyze your code for different weaknesses, and then devise an even more sophisticated attack. So this is bad, right? We want to prevent it, and it's really easy to prevent it because we should be using bind variables. Keep in mind, and I know I've seen this and I've probably said it, if you use a bind variable, you're safe. Well, not always. Most of the time you are. It's just where you're using the bind variable. So if you get into things like dynamic SQL, if you use a bind variable here, which that is, right, colon P1 empno, this is no better than this. So inside your dynamic SQL, it is absolutely essential that when you use your bind variable, you include it in the quoted text, because this is what gets executed. You don't want Apex to interpret that bind variable before it actually executes the SQL. Otherwise, you're just concatenating stuff into a string, which is really the guts of a SQL injection attack. So keep that in mind. If you're using it in your query in a regular, normal, interactive grid, interactive report region, bind variables right there are probably fine. It's when you start to get fancy and use dynamic SQL, execute immediate, DBMS SQL, things like that, that you've got to be a little cautious with it. DBMS assert is also there to help sanitize user input. There's a whole number of different functionalities that DBMS assert has. It was designed to guard against SQL injection attacks. Check it out. Here are some of the different functions that it does. Really the most important here, I think, are the in quote literals. We'll show you how that works in just a second here. But you could also say, is this a qualified SQL name? Is this a SQL object name, right? So you can pass in different parameters to determine whether or not someone might be trying to prod against your database into DBMS assert before you proceed. This is another area where you're going to get a little messed up, is when you're starting to do these cursors inside your PL SQL and you want to do some sort of variable, right? I'm passing in P code and I want to make sure that ename equals P code. So I need a quote, but I have to quote the quote. And now over here, I might need an extra quote to close it because I need one to close the string and then one to embed in the string. So I've played the game where you're like 3, compile, no, 4, compile, yes, yay, okay, good enough, let me move on. Well, what happens is when you pass in something valid like this, king, you get the right number, right? 7839 is the employee number. But when you pass in something like this, a little soup of encoded stuff, you get everything, and we don't want that. Or, again, here's another example of where I could do a union. So not only am I getting the employee ID of king, I'm getting a list of all the department IDs from a completely different table. This is a better approach. When you have that issue where you want to put a quote around a value, but that's part of a string, use DBMS assert in quote literal, always, always, always have sys as a prefix. This seems unnecessary, but worst case, and you're in bad shape if this happens, but it could happen. Someone may have created their own DBMS assert in a synonym, and that is a false DBMS assert. Even though it might do the same thing, they could be taking that data, storing it off in a table somewhere. So you always want to use the sys.dbms assert, sys.dbms anything. If someone messed with sys.dbms assert, I'm sorry, but you're too far gone at that point. Someone's in there, at the lowest possible levels. So here's your checklist. Again, I'm going to kind of breeze through these just in the interest of time, but these will be available for download in the slides. These are the things you should check for your SQL injection risks. Broken off. This one's popped up quite a bit in recent times. We've seen Apex authentication. We provide a set of credentials. Apex either lets us in or not. Apex really doesn't care where the credentials are coming from. It's literally a function that returns Boolean. You could conceivably create a authentication scheme that's guess my number. And you put in a number, and if you guess it right, you're in. Otherwise, you're not. That would be terribly impractical. So we usually use something like LDAP, or maybe in the HTTP header variable with a single sign-on solution. Or with the newer versions of Apex, the social sign-on, which essentially calls an API, and then the API system calls a callback URL. And if that API returns a true or the number one or whatever it does, we return a true to the Apex authentication scheme engine, and off you go. Any attempt to log into Apex that's valid or otherwise is logged. And this jumps ahead, I think, to A9 logging. If you're not looking in your Apex logs, it's the Apex workspace access log is the view. You have absolutely no idea how many people have tried to break into your system. It could be 1, it could be 1 million, it could be any number in between or above 1 million. You just don't know. So monitoring that is important. You will see invalids. People will mistype their password. People will think they're on one instance and they're on another. But if you see systematic attacks from the same user over and over and over again, or systematic attacks from the same IP address across a broad range of users that all fail, you can bet that someone's trying to break in. This is why it's really important to put that little countdown. Please wait 5 seconds. Please wait 10 seconds. Please wait 15 seconds. Every time there's an invalid set of credentials put in, it's going to increment that by 5 seconds. This will throttle somebody who's trying to throw 1,000, 10,000, 100,000 attempts at a single account. It'll make it really, really painful for them after they get around the 7th or 8th attempt. Once it locks your account, Apex now reports the account is locked. I don't like that. I wish they reverted it to where it just said invalid, because now as soon as I see the account is locked, I could adjust my playbook as a hacker. And if I know it only takes 3 times to lock an account, I'm not going to waste my time. I'm going to go wide and try to hack into lots of variations of usernames with 3 common passwords, knowing that after 3, I can't get in anyway. So it used to not say that, it does now. At least the account is locked. At the end of the day, it's no less secure. It just gives a little bit of information away. Your session in Apex is good until any one of these following events occur. Clicking logout, right? That definitely terminates your session. Quitting the browser, and I mean all tabs, all instances, not just the one tab that you're acting in. If you mess with the URL and mess with the session ID or hit a page where session ID, session state protection is enabled, that'll kill it. Session duration or session idle timeout is reached, that'll kill it. If the Oracle Apex Purge Sessions job runs, which runs every hour and kills sessions 24 hours or older, that'll kill it. If you mess with your cookie, that'll kill it. Or if you're an Apex Workspace administrator and you come in, you can manually purge sessions. So any of these events will go ahead and knock your session out. One thing to consider, it's not native, but it's not too difficult at all to implement, is some sort of 2-factor authentication. You can integrate it fairly easily with SMS, which isn't the most secure, but it's better than nothing. You could also indicate it with Google or integrate it with Google Authenticator or Microsoft Authenticator. That's pretty easy to do, where you get that little QR code, which you rarely use, but the QR code is just a quick way to enter in a code into the Authenticator app. Then every time you log in, you've got to provide that second factor. It's a rotating 6-digit code. Not terribly inconvenient, but definitely makes it more secure. Sensitive data. Lock your data down at the lowest level possible. This should be done hopefully with something like virtual private database, label security, perhaps redaction, or maybe even a secure view. If you do it at that level, you won't have to worry about it. So when you start building web services on top of your schema, you already have that security layer in place. You might have to tweak it a little bit, but at least it's secure, so certain users who hit those web services only see their own data. What's a secure view? It's not really an object in the database. I call it the economy class solution. Works on any edition. Really, all it's going to do is use what's called an application context to lock down in the where clause of the view. So that application context can only be set by calling the package or the procedure named in it. And we do that in Apex under the security attributes. There's a section that says init PL/SQL. That's where we call the context. We pass in a parameter. We go figure out who you are. We lock down all the data based on that context. Real easy to implement, doesn't take long. But again, it's kind of the economy class. It's not terribly flexible. But once you do it, anything that hits that view, you're good to go. A little bit better, a little bit more robust solution is virtual private database. This is a feature of Enterprise Edition. It is supported in XE 18 as well. What this will do is automatically run a function when you query a table or a view. So for instance, if you wrote this query in Apex, select star from employees, what really happens is the database will automatically add where department ID equals 10. And that'll get added. You don't have to worry about it. Anytime you touch the employees table, that function is automatically added. So if you look at a little sample data set here and I turn on VPD, even though there's 4 records in the database, my query only brings back 2 records, Scott and Brian, of course, in that order, because the database is smart enough to bring back smarter people before less smarter people. A little inside joke there. Anyway, benefits, it'll secure data at the database layer, works regardless of the technology. You can use this pretty seamlessly with the Apex app user value. Pretty easy to just kind of say, hey, is there an app user defined? If not, default to the user. It'll simplify your development because you don't have to worry about every single time you touch a table, you've got to add a where clause that's largely focused on security. It does make things like URL tampering, I wouldn't say irrelevant, but less of a concern. If there's more things you can tamper with in the URL than seeing data, but if you're trying to manipulate that URL to see records you're not authorized to see, you're just not going to get to see them with VPD enabled. You're going to get a no data found message. A couple more advanced features of it, column relevance, right? We might only want to turn on VPD if the salary column is involved. So in that employee lookup example, if I do select ename from emp, show me all 14 records. But if I do select ename comma sal from emp, VPD kicks in and says where emp no equals my employee number only. Column filtering is similar. It'll just display nulls rather than filter the records. And then obviously that application context is a key part of this. Label security is for cost. It's kind of the higher level feature, really built to enforce regulatory compliance. I know the federal government likes this feature a lot. It also does have a little bit deeper integration with database vault as well as identity manager. It works like this. You add a column to your table and you create labels. And then depending on the user's classification, they will see everything at or below their label. So if this user here is a sensitive user, he will see sensitive and confidential, but not highly sensitive data. You could achieve a lot of this with VPD, but again, it's a little bit more of an architected solution, plus there's a cost to it. So if you could do it in VPD, that's probably your best bet. Lastly, redaction, introduced in 12C, but backported to 11204. This is part of the advanced security option. So you do have to purchase ASO for redaction to work. Prices here are a little bit dated. It may be the same. It may not be the same. Check with your rep, obviously. This will redact data, not modify data. The source data is always going to remain unchanged. This is really good for a call center, a hotel, an airline, right? All places where we want some data to be exposed, but not all the data. Typically, you call one of those call centers, they may ask you the last 4 digits of the credit card you used, last 4 digits of your social. They shouldn't see all the digits. So with redaction, we could take this same data set here and redact most of the social security number, but provide enough so that it still identifies the user. We could do full redaction, which replaces values with a space for a varchar, 0 for a number, January 2001 for dates. We can do partial, which is what I just showed. We could use regular expressions to go out and look for patterns and match those patterns and then redact content. Or we could just replace stuff randomly, which I think is the most fun. Your salary changes as you keep reloading the page. Now, masking and subsetting is very different, and I know that people have confused these two. What this is designed to do is change your data before you kind of demote it from prod to dev. So maybe you've got a performance problem and you take that data from prod and you copy it over to dev, and now you start prodding and tweaking it. You don't want everyone to see the true production data. So data masking will go in and scramble values. This is kind of undoable, right? So you don't want to use data masking to obfuscate everything in a credit card except the last 4 digits, because you're going to have a real bad day when you try to get that back. So 2 completely separate solutions for 2 completely separate scenarios here. Now, one warning about redaction: it doesn't get applied in the where clause, meaning if, let's say, I redact the salary and I look at a report and everybody's salary comes up as XXX, if I take an Apex Interactive report and apply a filter and say where salary greater than 50,000, I'm going to see a subset of rows now where the salary is greater than 50,000. It'll all still say XXX for the salary, but I know these people make over 50. And then I change it to say between 50 and 100, or between 100 and 110. I don't know exactly what each person makes, but I know their range, and that's more than enough for me to do a lot of damage to a company. So make sure, if you're going to use redaction in Apex in an interactive report or grid, disable the option to filter on that column. Otherwise, you're just making it a little difficult for someone who's dedicated / malicious to sit there and play with the data to figure out who makes more than me but does less work than I do, print that out, and, like I said, cause a lot of HR problems. This one goes without saying, but I still have interaction with people who don't use HTTPS or TLS. It's crazy. Absolutely need it in between your browser and your web server. You can go to Let's Encrypt and get it for free. You can buy certificates. I don't care. Use temporary certificates. Use a self-signed certificate. At least it's secure. It'll freak out, and that's really not a good idea for prod, but at least it's securing your data. It is trivial for someone who wants you to listen to that traffic if it's not encrypted and pull stuff off the wire. There's also additional options you can set in Apex. At the instance level, you can say, hey, everybody needs this to be secure. I don't know why not always necessary for development is there. I need to delete that. And is there a way to draw over it? I should. You should have it everywhere. There's also 3 parameters to be concerned with for individual apps. Require HTTPS, outbound HTTPS, and then your HTTP response headers. These 2 should be turned on. This will be a problem if you're talking to a web service that's not secure. The number of not secure web services is probably getting smaller by the day, so I really wouldn't worry too much about that. Go to your application authentication scheme, cookie attributes, and there is a secure option. Set that to yes, and now your application will not even let anyone log in unless it's running over HTTPS. Item encryption. This is a small one, but this could have pretty big repercussions. Apex is going to store all your session state values in the database in clear text in a table called www-flow data. And if you looked at your Apex schema, which should be locked, but let's say you're on dev or on Docker or on your own instance, you could open that up, and inside www-flow data is user session states. This is where that new feature, only stored for the request, reduces the amount of data written to this table. Having said that, if you are writing to this table, a curious DBA Apex administrator can kind of pop in and view anyone's session state, even if you don't want them to. There's really nothing to stop them. If you somehow get a hold of the redo logs of the database, you could even scrape those and find artifacts such as credit card numbers, social security numbers, national identifier numbers, things that you thought was sensitive, but eventually ended up in clear text in a file. And if someone gets access to that file, bad news. It's really easy to do this. Go in any item that is sensitive that you wouldn't want people to see. Basically set store value encrypted in session state to yes. It's that simple. Do it across all your apps, all the items, and anytime you have anything written to disk, it'll lock it down and encrypt it for you. This is different now. I want to say, and I'm not 100% sure, but I think in 19.1, even if it's encrypted, it's going to show you the value when you look at the session state. That's kind of a debug tool, and I get and appreciate that because you can see it anyway. It was just a little bit weird before. If I were to query this, and here's what a query would look like if I somehow got into the Apex schema, here's the value, P3 salary set to 5,000. If I encrypt it in the session state, it is obfuscated, or it was. I'd have to double check to see what the deal in 19.1, 19.2, and 20.1 is. But I know for sure if you go to SQL Plus and encrypt it, you're just going to get a bunch of junk. Okay, I've got 10 minutes, less than 10 minutes to get through a bunch of stuff here. Authorization schemes. These should be created in every application. You should have at least one that you associate with the application that shortlists who can access that application. So many times have I been to clients where they don't have this and they're using LDAP. So anyone in the organization, from the janitor to the CEO and everybody in between who has an email account, can access any application because they haven't done this gatekeeper or this authorization scheme that locks down who has access. Really important to do that. There's a bunch of new features and APIs to help with this. Apex authorization is a relatively new API. Most people set it per session, which is probably fine and definitely the most efficient way to set it. But if you need something a little bit more secure, you can do per page view. Check the reports. You can see which pages are assigned and which pages have authorization schemes. That's something that every page should have something on it. It's not a bad idea to just create, a user role, and then every page gets the user role, because at some point that app will have 2 roles. And then you're going to have to go and set pages to either one or the other. So get ahead of the curve and create that user role and default it that way. Misconfiguration. There's not a lot you could do with Apex, but there's definitely some stuff that could be bad. Really, and I don't know if I mentioned in the slides, runtime mode. Prod should be runtime mode, and that's a special way to install Apex so that there's really no way to edit an application. So you can't change it if you can't get in and edit it. It literally removes the builder, but leaves enough bits of Apex so that you can still actually run applications. Logging should always be on. Debugging, it's changed. I forget whose session it was early this morning. I was watching one of them. Might have been Peters, who showed the old way of debugging where it would render everything in line. It was way more important to turn it off back then. Now it's not as important because you can kind of programmatically turn it on and off. Compatibility mode, set it to the most recent version of Apex and then make sure you test your app. You might find some things don't behave the same way. Availability and build status, again, if it's on runtime mode, this doesn't matter. If you don't have your production on runtime mode, you want to make things run application only, and then selectively change it to run and build if for whatever reason you want to go into prod and mess with your application. Every app should have an error handler, even if it doesn't do anything. Again, if I could get Apex to generate errors, I could start seeing things like package names and line numbers and all these little bits and pieces of information that I might not be able to do anything with except use as a social engineering vector, right? It's a lot more convincing if I look you up on LinkedIn, find out who your boss is, find out what department you're in, generate an error, get some information about it, maybe use some SQL injection with that to prod the vendor table to find out what vendors are there. And then when I call somebody else who works for your boss from the help desk, I could say things like, I'm working for Cindy, the VP of Finance, and she asked me to work with the consulting company people. We're troubleshooting this function called calculate interest, and I keep getting an error on line 100. Can you just reset my password? I sound a whole heck of a lot more credible with all that information. Hopefully people will kind of catch on that it's not legit, but there's a lot of bad people in the world and a lot of bad stuff going on. So wouldn't put it past me that someone has already tried to do something like that. Kind of skipping through here, we talked about authorization schemes, session timeout. This typically is set to 24 hours, 8 hours of session duration and 1 hour of idle time. If that's not good enough, you could adjust that per app. If it's too good, you could also adjust it. We talked about session state protection. Just a couple other things. Caching, you should have this disabled. Frames, that's going to change when Chrome 80 comes out. Embedding things in frames. There's a good post by JMJ about what you're going to have to do in order to adapt to that. And make sure your escaping mode is set to extended. Just trying to see here, skipping through a couple things because I do want to cover a couple more sections here. Here's your checklists. Probably the last section I'm going to have time to cover here, cross-site scripting. Think of this as SQL injection for JavaScript, right? That's kind of the easiest way to understand it. What happens here is typically I want to create a report and my users, for whatever reason, want address 1, address 2 to be on top of each other. So I put a BR in there and I notice that the BR renders. And I'm like, that's weird. This is HTML. Why is it rendering that? I start messing around with all the column attributes, and way down at the bottom, I see escape special characters. I set it to no, and voila, my 2 addresses render on top of one another. The BR disappears. It's being interpreted. Mission accomplished. Wrong. I just created a cross-site scripting vulnerability. And again, these are only limited to time and expertise. So by doing it that way, I can now inject some JavaScript, and the JavaScript can do all kinds of real bad stuff. Better approach, look at your HTML expression attribute. You could then put in pound address 1, the BR HTML tag, pound address 2. Apex will escape the column values, but it won't escape the hard-coded HTML that you've put in there, which is harmless. It's just a BR. So what happens here is that bad.js file gets downloaded or code gets executed. That bad.js might be smart enough to say, hey, I'm going to go grab the JSON file that's the source of an interactive grid, and I'm just going to take that file in its raw form and bounce it up against a web service. And that web service is just going to store it in my database. And later on, I'll go back and take a look at all that stuff and parse through it and see what it is I got. You can restrict input, but keep in mind that's only blocking one door into your data. If you have data coming in through external sources or older technologies or another HTML platform where they're not restricting input, this only blocks that one door, which is your Apex app. So it's a good idea to do this, but don't think this is enough. This is only one area that you have to be concerned with. You could always use Apex Escape if you want to render something on a page and you feel that that data may have been compromised somewhere down the chain. Check it out in the API document or the API guide. There's a ton of different options you can escape, not just HTML, but if you're preparing JSON, LDAP calls, they all escape slightly differently, and each one of those has a supported API as well. I'm going to skip to the checklists for these because we're running out of time. Stay current. Absolutely critical to stay current. If you're running an older version of Apex, there are definitely known security exploits out there. You want to make sure you're up to date. This is a bigger soapbox than we have time for, but use the built-in stuff. Don't try to build your own components if you're not familiar with the technology, because the more you stay outside of the Apex supported box, the harder your upgrades get. Subscribe to and apply patches referred to in the Oracle security alerts, and keep an eye on industry publications as well. Check your logs. Apex tracks a lot of stuff, but it only keeps 2 weeks of data. So Apex Workspace Activity Log is one, and Apex Workspace Access Log is the other. If you're not watching these, you have no idea what's going on. Is someone running SQL Map against your database? Maybe. There's no feature in SQL Map that says identify owner, right? They'll run it and they'll run it all day and you'll have no idea. You might get excited because your page views went up and all of a sudden you have more interactions. Well, that could be SQL Map just hammering the database trying to find a way in. These only get backed up these only keep 2 weeks of data. I don't recommend you increase that window. You'll run into other issues if you make it too big. Create a job that just dumps yesterday's data every night, and then you can archive that. This is more for forensic purposes. You can't get it back, right? If there was a breach and someone wants to trace that breach back 2, 3, 4, 5, 6 months, and you only have 2 weeks of data, that's bad. So keep it stored. You don't need to have it performant. You don't need to have it do anything. Just keep it somewhere so that in the case you need to go back and look through it, you have all that data. Okay, let's take a look at some of the questions here.
Okay, so we've got a few, just a few.
Make sure I'm getting a little beach ball here. I don't know what Keynote's trying to do, but let's start with the questions while I'm working this out.
Can you hear me, Scott?
I can hear you.
Okay, good. Okay, so question number one, can you talk about security of AJAX calls in the Apex environment? It doesn't seem that they contain any checksum, much like the submission of a page does.
Right. So an AJAX call, you really want to use the proper Apex server process to do that, because that will, when it gets into the PL SQL side, that AJAX call will first run the init PL SQL. So if any context needs to be set, it'll set it, and then it'll have the cleanup PL SQL at the end of that call as well. As far as checksums, you're right. I mean, it's just going to do whatever that PL SQL procedure does and bring back whatever data it happens to bring back. The onus is on you, the developer, to make sure that if you're setting an item via an AJAX call, a lot of people, what they'll do, particularly with hidden items, is they turn the protection off. Otherwise, they get that weird error when they go to submit it. you've got to have another backup server-side validation that no one can tamper with in order to make sure that it gets set properly. So, for instance, job code. If based on my user, it goes out and asynchronously populates a select list with eligible job codes, and then somebody manipulates that and changes it to one that I was ineligible for, you probably want a validation that says, okay, we just set Scott to job code 9. Was that a possible job code? No. Flag that as suspicious, right? And don't let that transaction proceed.
Okay, next question. Is Apex Escape better or the same than DBMS Assert, or are they completely different?
Totally different. Apex Escape is just going to basically render a string safe to be emitted in HTML. DBMS Assert is really a SQL side thing that's looking at, can I end quote this literal, right? I've got a whole bunch of single quotes in this string. Let me create the first real quote and the last real quote, and then just shove that whole string into the variable there. So they're used together, but they do very different functionality. They serve very different purposes.
Okay, next one. Is there a utility to identify pages or items that are prone to SQL threats like URL tampering, SQL injection, etc.?
There are two. One is called Apex Sec. It's a commercial tool that you could purchase that will analyze your whole application and identify a bunch of common things that are wrong with it. The other one is called Apex Cert, which yours truly and yourself had a lot to do with that one. It's still dated. It's stuck on 5.1. I do want to get it to 19.2. I think that's going to be the next release we move it to. That one is an Apex app that actually installs, kind of like Apex does, in a central workspace. You could then evaluate all your apps according to Apex Cert's rules. What I like about Apex Cert is it has the ability to flag false positives. So if, for instance, you have a public page and you want a public page, you could say ignore that. It's also database based, so you could have 4 or 5 developers on Apex Cert all running evaluations and kind of collaborating together in the same place. But I do need to update it. I know someone in the community updated it to 19.2. Haven't had time to take a look at all the specifics of what he did to it, but it's on my list. It's a long list, but it's on there. It's getting up to the top of it too.
Okay, so another one that you may or may not know is VPD. Since you mentioned VPD, is VPD available and supported in ATP and ADW in the cloud?
I believe it is. Don't 100% quote me on that. If anyone from the Oracle side knows the definitive answer, but I'm pretty sure I tested it when ATP was first released, and VPD is there, but I could be wrong.
Okay, next one is how would you be able to add security such as session state protection to cascading select list? It gives an internal server error if I try to add session state protection to those items.
Yeah, you have to turn it off and just handle it on the back end there, right? And that's some of the tricky things is when you start doing the JavaScript side, Apex can no longer, because really what's happening is you're changing a hidden value, or you're changing a value that Apex thought was A when it rendered the page, and now it's B, so it flags that as suspicious. So you've got to disable it, and then you just put in something on the server side that does that secondary check, right? And there's really no other easy way that I'm aware of to change that.
Okay. One about modal dialogues. Modal dialogues designed to be open from a specific page, say page 2 or page 202, are actually accessible from the console from any page or from any page using Apex navigation dialog. Is there a way that you can secure that so it can't be open from any random page? Is there a best practice? How would you approach that?
It's just another page. So if you've put authorization schemes on all your pages and you're locking them down based on users and user to role mappings, even in the console, you should not be able to see those pages if they've been locked out otherwise. That's what I love about modal pages is they're just pages. Every single thing about them is identical except for the fact that it pops open in a window. right? So once you get in the habit of creating a page, making sure you put the right authorization scheme on that page, that habit just flows into modal windows seamlessly, typically.
Okay. Can I generate a new checksum for every page view? Now a checksum is generated based on a combination of arguments and values. As long as the arguments and values don't change, the checksum generated is always the same. I need the checksum to be deprecated once the page is viewed.
I don't know of any other way than if you were to make sure it's per session, but I don't think there's an option for page. It's just page must contain checksum. I don't think there's a way to say rotate checksums or do it differently. I'd have to double check. Maybe in 21 there's something, but.
Okay. Another one, when you were talking about
I guess, it should be different per session, right? So once you log out and log back in, it'll be different. I'm not sure what the concern is. If I'm just reloading the same page, it's going to be the same URL over and over and over again. But if I log out and log back in, that same combination. So if I'm editing record 10, for instance, should have a different checksum because your session ID definitely plays into the generation of that checksum.
Okay. Couple more. We're getting close to the top. One more. You seem to skip over it a bit when you talked about it, but would you suggest for data masking between prod and non-prod environments when you're carrying out environmental clones? What would you suggest there?
It depends, right? I mean, if your data is very sensitive, then yeah, data masking is really important because keep in mind it's custody of the data, right? If you have 20 developers and 2 different contracting companies, who's to say that those people aren't either sharing their IDs or are they practicing good data management? If I'm going dev and I want to download a spreadsheet worth of stuff and send it to a business user, right? If I have all that sensitive data in dev and I want the business user to tell me like, hey, did the formula work? Here's a spreadsheet of 5,000 rows. Now there's a spreadsheet that contains what we thought was production data that I just pulled out of dev, and that business user doesn't encrypt their drive or opened it up on their iPad and walked away and someone stole it, right? There's all kinds of things that can happen to the custody of that data. So it's real important to make sure that sensitive data stays on prod because dev environments are just not managed the same way. I mean, let's be honest, in a lot of shops, people have their own local Dockerized dev instances, or it's real easy to clone dev, or everybody has sys for dev because the DBA is tired of the developers asking for all the stuff. So the sys password is manager, and it's really easy to get to.
Okay, and I will leave you with this last comment in the chat. Great session, but now I'm not going to be able to sleep tonight thinking about all of my security issues that could possibly come.
Yeah,
and with that, we'll end.
Then there's a couple security books out there you could read to kind of lull you to sleep. I recommend the API guide if you're really struggling. Start at A and go through the whole thing. You'll learn a lot, but you'll probably become a little tired. It's not a joke anymore. I mean, it's funny to joke about security, but it's just getting so bad, and there's so many more people who have their hand in it. I mean, I could probably teach my son to do SQL map. It's not that hard. It's just a script, and all you got to do is point it at a server, and off you go. So the number of people who are trying to break into systems are increasing. The number of tools out there that make it trivial to attack these systems are also getting easier to get and easier to use, and those are increasing. It's a constant battle. It is really hard and it is exhausting. So yeah, take it seriously. I mean, get some sleep. Don't not sleep. But with all this extra time we have, it's not a bad idea to kind of review our security postures.
All right, Scott, we're at the top of the hour, so we got to let the next one go in to keep on track. But thanks so much, and on to the next one.
Thank you.
All right.
And thanks everybody for organizing this.